Hey students, so today in class we'll be finding the area of rectangles, triangles, circles, and compound shapes and putting them into real life use. Before in class, we had learned to find the perimeter of a shape. This is adding together the outside lengths of the shape. This is different from the area because we are now measuring the total surface taken up by the shape. The definition of area is the size of a surface, the amount of space inside the boundary of a flat two-dimensional shape. When solving for area, every shape has a different formula. For all the problems that we will be working on, the measurements or dimensions of the shapes will be given, or we will measure them out ourselves using a ruler. When solving for area for a rectangle, you have to know the base and the height of the rectangle. When in an equation, the letters b and h are used, b standing for the base and h standing for the height. When the base and the height are multiplied, that will give us the area of the rectangle. Area is measured in units squared. This is very important to have in your answer when solving for area. Here is an example of a rectangle on a piece of graph paper. To find the area of this rectangle, you can count the length of the base and count the length of the height. The base of the rectangle is 7 and the height is 11. You then multiply these numbers together, which gives us 77 units squared as the area. When a rectangle problem acts like this on a graph paper, you can check your answer by counting the total number of units within the rectangle, and that will also tell you the area of the shape. So here we can see that there's a total of 77 units within the 7 by 11 rectangle, showing that the area taken up by the rectangle is 77 units. To find the area of a triangle, the equation is similar to finding a rectangle, but it is 1/2 base times height. Triangles are a little more trickier to find the area because the height can be found in different places for different types of triangles. For a right triangle, the height can be found along the side of the triangle that is connected to the 90-degree angle with the base. For other types of triangles, the height is the length from the highest point of the triangle to the base of the triangle, like so. For the problems that we will cover for now, the height of the triangle will always be given. Here is an example of finding the area for a right triangle. The base of the triangle is 8 units in length, and the height of the triangle is 9 units in length. 1/2 times 8 times 9 is 36, giving us the area of this triangle, 36 units squared. Here's an example of finding the area of a non-right triangle. The base is 7 units in length, and the height is 7 units in length. 1/2 times 7 times 7 is 24.5, giving us the area of this triangle to be 24.5 units squared. Here is another example of finding the area of a non-right triangle. The base of this triangle is 10 units in length, and the height of this triangle is 9 units in length. 1/2 times 9 times 10 is 45, giving us the area of this triangle to be 45 units squared. Next, we will find the area of a circle. The area of a circle can be found using the equation A equals pi r squared. As we learned in past lessons, the radius of a circle is the distance from the center of the circle to the outer edge. This will be the only number needed to find the area of a circle. Here is an example of finding the area of a circle. Using the graph paper, we can count that the radius of the circle is 5 units. We then plug this number into the equation A equals pi r squared into our calculators, giving us the area of 78.54 units squared for this circle. Finding the area of something is used in the real world every day. Things like calculating the correct amount of wall tiles or flooring are common ways of calculating area. It can also be used to find the amount of room for putting a TV on a wall, and even to find the amount of space that there is in a garden bed for plants. Here is a real-world example of finding the area of a rectangle. First, we have to measure out the length and the width of the garden bed. We can pretend for now and tell you that the garden bed is 22 feet by 12 feet. Now that we know the measurements of the base and the height of the garden bed, we can use these numbers to find the area. Remembering that to find the area of a rectangle, the equation is area equals base times height. We now know to multiply 22 by 12, giving us the answer of 264, making the area of this garden bed 264 feet squared. Finding the area of this garden bed is important when planning a garden, to know how much space there is needed for the plants and seeds. Here is a real-world example of finding the area of a right triangle. Say that these shelves are placed in a corner at someone's house, and that person would like to know the area of this shelf so they know how much space is on it and can plan what to place on it. For this example, we can look at the bottom shelf and know that from the photo that is taken on an angle, the surface of the shelf is a right angle and looks like the triangle I have drawn out for you. We know this triangle is a right triangle because it is placed in the corner of a room, giving it a 90-degree angle edge. Say that the base and the height of this triangle was 14 inches. We would then plug these numbers into the equation to find the area of a triangle, which is area equals 1/2 base times height, which would give us the number of 98, giving us the area of this triangle to be 98 inches squared. Next, we have a real-world example of finding the area of a circle. Let's say that you are trying to find the area of the top layer of pie crust needed, so you know if you have enough dough to make it. For this example, we will say that the diameter of the pie pan is 4 inches. Now knowing the radius, you would plug the number 4 into the equation to find the area of a circle, which is area equals pi times radius squared. You would get the number 50.27. So the area of the top pie crust is 50.27 inches squared. Lastly, in this lesson, we will go over finding the area of compound shapes. Compound shapes are shapes that are a mix of different shapes. Shown here would be an example. This shape can be looked at as a combination of a square, circle, and triangle. When solving the area of a compound shape, all the different equations for different shapes have to be used. When solving for the area of a compound shape, you have to look at the shape in separate pieces in order to organize yourself to find the shape's total area. As shown here, this is the exact same shape that was in the last slide, but it is now broken down into different shapes that we can find the area for, and then add them all together to find the compound shapes area. This makes solving the area for compound shapes a multiple step problem. For this problem, you have to solve the area for a rectangle, then solve the area for a circle, which you will then divide in half since only half of the circle is in the shape. Then solve for the area of the triangle, and then lastly add together the areas of the half circle, rectangle, and triangle to find the compound shapes area. Here we will go over an example. So here on the graph paper, the compound shape is shown in its original form. From that form, we can isolate that there's a rectangle, triangle, and 2 half circles to make a complete circle. Given the measurements for each shape, we solve for the area of the circle using the equation A equals pi r squared. So pi times 4 squared is 50.27. We solve for the rectangle using the equation A equals base times height. So 8 times 17 is 136. And then we solve for the triangle using the equation A equals 1/2 base times height. So 1/2 times 9 times 13 is 58.5. Lastly, we add all of the found areas together. So 50.27 plus 136 plus 58.5 is 244.77, giving us our compound shapes area, which is 244.77 units squared. Solving the area for compound shapes can be a little tricky, but it is important to just remember these steps and keep your work organized, and these problems will become quite simple. Here are some examples of how finding the area of a compound shape can be used in the real world. In the real world, perfect shapes are not common, and compound shapes can be found in lots of places. When looking at blueprints for houses or plans for a backyard garden, compound shapes are commonly used. From the real-world blueprint example, we can use it to solve a real-world example to find the area of a compound shape. Say we need to know the total area of the first floor of this home to know the floor space. Although the blueprint breaks up this compound shape into separate rooms, we want to know the total amount of floor space. So this is technically solving the area for a compound shape. Here I have given you the measurements of the different rooms in the house. So as before, to solve for the area of this compound shape, we have to find the area of the other shapes and add them all together. First, we will find the area of the backyard porch. The radius of this half circle is 13 feet. So using the equation to find the area of a circle, A equals pi r squared, we calculate pi times 13 squared and get the number 530.93. We then divide this number in half since the backyard porch is only a half circle and not a complete circle, giving us the number of 265.465 feet squared as our area of the backyard porch. Then we will find the areas of the kitchen, hallway, and 2 closets, all using the equation to solve for the area of a rectangle, which is A equals base times height, since they are all rectangular shaped rooms. So for the kitchen, we will multiply 14 feet by 16 feet and get the number 224 feet squared as our area. Then we will find the area of the 2 closets, which are both 6 feet by 6 feet, giving us the area of 36 squared feet each. So a total of 72 feet squared total for the 2 closets. And lastly, for the rectangular shaped rooms, we will calculate the area of the hallway, which is 26 feet by 3 feet. So when we multiply them together, giving us the area of 78 feet squared. Next, we will calculate the area of the 2 triangular rooms, the office and the library. Both of these rooms have a base of 12 feet and a height of 10 feet. And using the equation A equals 1/2 base times height, each room has the area of 60 feet squared. So a total of 120 feet squared for both triangular shaped rooms. After all of these calculations, we just have to add up all the room areas. So 265.465 plus 224 plus 72 plus 78 plus 120 comes to a total of 759.465 feet squared for the area of the compound shape. That is all we have for today's class. I hope you enjoyed learning about finding the area of rectangles, triangles, circles, and compound shapes. Have a great day.